Hello, everybody. We are here today to talk about the Polygon sum conjecture. Okay, so you already know that there's 180 degrees in every triangle. Okay, so we're going to use this to determine the number of degrees in any other polygon that we want. Okay, so let's start with a quadrilateral. 4 sides. We can draw one diagonal across it that divides this thing into 2 triangles. Now we know that these 3 angles right here add up to 180. We know that these 3 angles right here have to add up to 180. And we also know that the 6 angles that we have here make the 4 angles of the quadrilateral. So there must be 180 times 2, or 360 degrees in a quadrilateral. Okay, and this is true of any quadrilateral. So we've got that figured out. Okay. Whoops. All right, so let's check out a pentagon. Now, we call this triangulation here. We're triangulating this polygon. So again, we have these 3 angles make 180. These 3 angles make 180, and these 3 angles make 180. So the 9 angles make up the 5 angles of the pentagon here. So there's 180 times 3, or 540 degrees in the pentagon. Okay. And Luna the Math Cat, of course, is jumping in here because she likes to participate in this kind of stuff. She's a very good geometer. Okay. So we move on to a hexagon. I'm going to let you do this one. Why don't you triangulate it into as many triangles as you can? From one notice it's always from one vertex, okay? So I don't just make the diagonals go willy-nilly across this thing. I pick a vertex and I make all the diagonals I can from that vertex, divide up into triangles. How many degrees, I want you to calculate how many degrees you think are in the hexagon, and then jump back on here and compare with what I get. Okay, so I would divide this like so. Okay, and I get 180 degrees here, 180 degrees here, 180 degrees here, and 180 degrees here. So that's 180 times 4, which is going to be 720 degrees. Okay, so there's 720 degrees in a hexagon, and I can divide that up into 4 triangles. Okay. Now, let's use this information here. We had 3 sides, triangle. We made 1 triangle that was 180 degrees. We had 4 sides. We made 2 triangles for 360 degrees. 5 sides made 3 triangles for 540 degrees. Okay, then this became 4 triangles, and that was 720 degrees. All right, go ahead and pause this video and fill out the rest of this chart and see if you can find the pattern for n sides. Okay? And then jump back on and see how you did. Okay, you can tell here that this started out 1, 2, 3, 4, and it's going up by 1 each time. So this would be 5, 6, 7. Okay. And each time here, this is going up 180 degrees. So if I add 180 to this is going to be 900. This is going to be 1,080. This is going to be 1,260. Okay, but what about this last one here for n? So if you look at the pattern, I had 3 sides made 1 triangle, 4 sides made 2 triangles, 5 sides made 3 triangles, and so on. So each time, this ended up being 2 less than the number of sides. So this is going to be n minus 2 right here. So I can make n minus 2 triangles, and then I take this number and multiply it by 180. So if I take n minus 2 times 180 will tell me how many degrees there are in an n-sided polygon. So this is my formula that I want right here. Now, using that formula, if I had something that said 20 sides, okay, I wouldn't have to draw a 20-sided polygon and then figure out, oh, there was 18 triangles that I could divide it into, and then all that. I can just plug it into this formula right here. 20 minus 2 is 18 times 180 would tell me how many degrees were in that polygon. Okay, you can find the measure of each interior angle of an equiangular n-gon by using this formula. Now, notice this has to be an equiangular. So all the angles are equal. All right, so in like this case, if I had an equiangular hexagon, which this is not exactly one of those, but actually, I think I have one here that I can do. Let's delete this and go get this one. There we got a nice equiangular one. Okay, so if I wanted to divide this thing up, 1, 2, 3, 4, like that, I'd get 4 triangles. Well, I don't even need to do that. I just need to put the number of sides into the formula here. So that would be 180 times 6 minus 2 over 6. Okay, so let's just delete these out of here. I don't need them. Okay, so this would be 180 times 4 divided by 6, which is going to be 720 divided by 6, which is going to be 120 degrees. So each one of these angles right here is 120 degrees in a regular hexagon. Okay, this formula works great because it's just as easy to do one that had, say, 75 sides. I could figure it out very easily. It'd be just as easy to do as doing this one. Okay. All right. So find the measures of the angles in the figure below. So I have no numbers on this thing. How can I figure out the angles? Well, I do know this. I have here a regular pentagon. All the sides are the same. Okay. And so what I'm going to do is I'm going to figure out how many degrees there are in this polygon right here. So there's 5 sides. 5 minus 2 times 180 tells me how many degrees there are inside the pentagon. And then I'm going to divide that by 5. And that's going to be each one of these interior angles. Okay. So this would be 3 times 180 over 5, which is 540, divided by 5, which is 108. So each one of these angles is 108 degrees. So now I know A. But I also know all of the, whoops, that's not 180, that's 108. Okay, now, that doesn't help me get C or D yet, but it does tell me what B is. Okay, so B is going to have to be 72 because these are a linear pair, so they must add up to 180. Okay, now that gives me this angle right here, because this is a parallelogram. Okay, so in a parallelogram, these two angles, two adjacent angles like this, have to add up to 180. So this also is going to be 108 degrees. And then that gives me D, because if I made a complete circle right here, there'd be 360 degrees in that circle, and I've already used 108 right here, so I'll take those out. That leaves me with 252, and there's 108 right there. I'll take those out, and that's going to leave me with 144. So this angle has to be 144 degrees right there. And I've now found all the angles that I could even find these other ones. I know that in a parallelogram, so this is a parallelogram, this is parallel to this side, so if this is 108, this has to be 72 right here, and then that means that this has to be 108. I can solve this entire thing. And I didn't know one of the angles to start with. Okay, let's talk about exterior angles. Okay, so an exterior angle of a polygon is an angle formed by extending a side of a polygon beyond the vertex. So basically here I took this side right here and I extended it here, took this side right here and I extended it here. Each angle in a polygon has two exterior angles, okay? Now, x and y are exterior angles because an exterior angle will always share a side with the vertex. Notice this flashing right here. Angle Z is not an exterior angle. Why is it not an exterior angle? It doesn't share a side with the polygon. It only shares the vertex. Okay? So, there's some things that I know here. Angle Z is going to equal this angle right here. And these are vertical angles. Okay? So if this was a regular polygon, we've already figured out that, that these would all be 108. Okay. Which means this is also going to be 108 right here. And then this would have to be 72 because it's a linear pair with that. And this would have to be 72 because it's a vertical angle with that. Okay, so the exterior angles on these are 72 degrees. Now, we have an exterior angle sum conjecture, and it says for any polygon, doesn't matter how many sides it has, the sum of the measures of the exterior angles, if I take one at each vertex, is always 360 degrees. So notice I only have one exterior angle at each corner, okay? And if I add up, let's see, angle V plus angle W plus angle X plus angle Y plus angle Z, that will be 360 degrees. Now, why is it 360? Well, here's the deal. Let's pretend that I was standing right here, and I was walking this direction. And I walked until I reached this point right here, and I turned this number of degrees. Okay? Now I'm walking this direction, and I keep going until I get here, and I turn this number of degrees. Now I'm walking here, I walk to this point, I turn this number of degrees. I'm now going this way. I walk to here. I turn this number of degrees. And I walk back to where I started, and I turn that number of degrees. What did I do? Well, I essentially just turned in a circle. I'm going the same direction that I was originally. Okay? How many degrees in a circle? There's 360. Okay? And it doesn't matter how many sides or corners this thing has, it's always going to add up to 360 degrees. Okay, so I got a nice little worksheet here for you. I hope that you enjoy that, and I will see you in class. Have a great evening.